So the goal of today's game is or video is to make the game Pong, which involves two paddles facing off in sort of a ping pong or table tennis or just tennis situation. So first thing I'm going to do is I'll make a white screen, and that is shown there. Oh, black screen. Let's make it a white screen. That is shown there. Let's keep it black, and let's move it to let's put a line down the center, just to denote sort of the halfway mark, and we'll say stroke weight 2, and make it a black line. Oh, let's say a green line. So let's sort of do this green theme, this green and black theme, to make it sort of old school. And let's make a line down the center from from width over 2, 0, to width over 2, height. This will draw a line down the center, a green line, and you can see it goes sort of straight down the center. Now, I should also sort of do a score setup. So this is the midline. Let's sort of have two integers. Score 1, set it to 0 to start, and score 2, set to 0. And we'll show those on the screen in sort of a nice little format where we say score display, and we'll want one on the left side of that line and one on the right side. So we'll say we have a text size of, let's say 50, nice big font. We'll put this sort of a quarter of the way through, and we'll say it's green font. And text score 1, width over 4 minus 25, height, let's say 50 down. Let's see what that looks like. Perfect. That's pretty close to what we want, so we'll keep it. Then we'll want the same thing, but in width over 4, let's say 3 times width over 4. So in this case, we get another score, still score 1, sort of offset the same way. 25 might not be exactly right, but it's close enough. So instead of score 1, we'll say score 2. Now we've set up a score display, we've set up a midline, now it's time to make our game. Our game depends on a few things. One of them is a ball, so we'll make a class for the ball, and one of them is a paddle. We'll make a class for the paddle. And the ball should have a few different variables. It should have floats for x, y, with radius, a vx value, and a vy value, a velocity value in both the x and y direction. We're going to assume that the ball is going to be green, so this should be sufficient for setup. We'll have a show method to show the ball, and a move method to move the ball. And the show method will just be a fill of green and an ellipse with twice the radius for the major axis and minor axis. So in this case, we're going to have a default value for x to start with width over 2, and a default value for y as height over 2. So we start in the center of the screen. We'll say the radius is about 10. We'll say the Vx starts out being 0, and the Vy starts out being 0 as well. In general, when we move, we want to say that the x value is increased by Vx and the y value is increased by Vy. And we'll start out by making a ball. We'll declare the ball. We'll initialize it and instantiate it. And then in here, what we'll say is, we'll keep this score stuff down there. We want to show the ball, and we also want to move the ball. Now, right now, moving the ball will do nothing because the velocity is 0. If I run this, I should get a ball in the center of the screen, and I have my score set up. I don't have any paddles yet. So let's see what happens if I just have a Vx of 1 and a Vy of, say, -1. Should move up that way. Positive in the x direction, negative in the y direction. It doesn't stop at the edge of the screen, though. The way I want to do that is I want to say if the x, we only want it to bounce off the ceiling, because if we move through the sides, one of the players will get a point. If x is equal to, or if y is greater than, or if y is greater than the height, or if y is less than 0, if we've gone beyond the edge of the screen, what do we want to do? We want to switch the Vy to be the other direction. So we want to start moving the other direction. I should include the radius here. Use the proper symbol. And let's see what this looks like with a big Y value. We should bounce off the top, but move through the sides. What this effectively says is that I go through the top. If I'm below the bottom of the page or above the top of the page, I want to switch my direction. This means or. Now, what can I do next? Well, this is sufficient for moving, but perhaps I want to set a random value. If I set from -10 to +10, I have an equal chance of going negative and positive, but I average out to 0. So this is not the most effective way to make sure I go in all directions, although it will, on occasion, get me to that set of circumstances. The best way would be to have another if statement where we have sort of a segmented value of like -5 to 10, and we choose between that and 5 to 10, and then same deal with my y values. I'll leave that for you to solve. We're going to move on to generating our paddle. First, we'll do one paddle with just an x, a y, a width, and a height, and perhaps a Vy, because we only care about moving in the up and down direction. So we know that our paddle will start with some default values. Good place to start would be that the width of my paddle is maybe 20, make it a thick paddle. The height maybe 80, just to make it sort of easy to work with. We can say the x value is equal to the width, or the x value is going to be equal to the height. No, 0 should be sufficient, but the y value is equal to the height over 2 minus h over 2, so minus 40. So when I make this, first thing I want to do is say, okay, well, I'm going to show this paddle as a rectangle. That's green. Simply like that. And I won't even worry about moving it. Move will only work for, I'll only do move for an AI paddle. Do my formulaic instantiation. Just want to show the paddle here. And this should appear right about here as a green paddle. Now, it won't interact and it won't move. Let's say I want to do mouse movement. I could say that p.y is equal to mouse y. That means that wherever my mouse is, my paddle is going to move there, as long as it's within the screen. So this way I can respond really quickly to someone's action. If I want to have another paddle, maybe I'll make a paddle P1. I'll say P1 equals new paddle. Maybe it's my enemy paddle. And I'll say that it starts at a different location. The X value is equal to the width of the page minus the width of the paddle. And if I want to show this, I simply say p1.show. This should be p1 up here. I don't move it, I don't change it, it's just going to sort of show up like so. Now, how do I have these paddles interact with a ball? Well, the most effective way is sort of to harken back to the brick breaker video. I'll deal with key pressed later. The way we deal with the paddle in brick breaker is we have an alternate method. But what I'm going to do here is I'm going to have an interaction. So I will do a void check, and I'll take in a ball. And what I can say is that I have a ball top, and that ball top is the by plus, minus br. I have a float ball bottom. So where's the bottom of the ball? It's at by plus. And all I'm doing this for is to look for interactions. If I've interacted the ball with the paddle, then I reflect. And again, I encourage you to draw this out. And I'm going to compare these to my paddle values with an if statement. So what I'll say is if, well, what do I want to compare? I want to say, is the ball inside the paddle? But an easier way of thinking of this is, when is the ball not inside the paddle? Well, the ball is not inside the paddle when the ball top is greater than, meaning it is below the bottom of my paddle. It is below the paddle bottom. The paddle bottom here is y plus h. Or the ball bottom is less than y of my paddle, or the ball right is to the left of my x value, or the ball left is further along than my x value plus the width. This tells me when I'm not interacting. But when am I interacting? I'm interacting when all of that is not true. Alternately, you could switch all symbols to their opposites. So saying less than or equal to here, and greater than or equal to, and greater than or equal to, and less than or equal to, and that is it, based on De Morgan's laws. So here, what I can say is, if this is the case, if I do collide, I want to switch the ball's x velocity. And that's all I want to do. So if I interact, I just want to say here, p dot check b and p1 dot check b. And I'm checking now to see if I've collided, which obviously I have the ability to on one side. There are a couple more things that we have to implement. One of them is how to deal with the score. Another one is how to deal with the ball respawning in the center. So one thing we can say is if the x value is greater than the width, or the x value is less than 0 for the ball, x plus r if x minus r is greater than the width, meaning we've gone off the page, or x plus r, the right side of the ball, is off the page, what do we want to say? We want to reset the ball. And what does it mean to reset the ball? It means the ball x equals width over 2, y equals width height over 2, and we want to reset maybe the velocities. So I'll go up here, and I will again randomize my velocities. And so what this will do is it'll ensure that I have, just for clarity, I'm keeping that there. It'll ensure that I have some remedy when the ball goes off the page. Now, one thing this might be, the problem here is that we haven't changed the score at all. Now, because these are global variables, I can actually separate this. What I'm going to do is I'm going to take this and I'm going to move it into something called reset. And reset will be sufficient to reset the ball. And now what I want to say is if in my game file, because this deals with the game, this is my game logic, if the ball x value minus the ball r value is greater than the width, I've gone off the right side of the page, so player 1 should get a score. I reset the ball and increase score 1. If b dot x plus b dot r is less than 0, if I've gone off the left side of the page, I'll reset the ball, and score 2 will be increased. And then, one thing I can do is at the very bottom, if score 2 is greater than or equal to 10, maybe I want to wipe the screen. And if score 1 is greater than or equal to 10, maybe I want to wipe the screen. Then maybe I want to put something like Player 2 wins, and then we'll do the same thing, and this will be actually width over 2, center of the screen. Then we'll subtract about 50, 100. We'll do the same thing in the case that player 1 wins. And let's see how this plays. So we have a random velocity that's probably not great. It's more a 0 along the y direction. So here we go. I got 1, 2. So this is where your optimization of your velocity would be helpful. 3, 4, and 5. This one's going to be a little long. You'll notice that there is no way that I have increased the speed in any direction based on where I hit, which is something you should do if you do build a Pong game. Well, that was a default win for them. But in general, we're playing this game, and it sort of functions almost exactly like I want. There's a little bit of an issue with swiping the ball in the side. But you can see that I have player 1 wins, and if I wanted to make this a little bit better, maybe I'd make the entire page a little wider. So maybe I'd make this 1,000. And we still get the same relative locations of my objects. So this is, in essence, the Pong game without an AI. To make an AI, we can make a track method for the paddle. So it tracks a ball. If I pass in a ball, it will try to follow it. So if the y value is greater than b dot y plus b dot r, if I'm below the ball, I'll subtract from my y, is less than b dot y minus b dot r, y plus plus. And you can change that value to increase y by some other number to have it track a little bit better. Now, in order to use that, I have to say the paddle that's tracking needs to track the ball. And I can run this game, and it will try to track the ball. And notice it's switching direction. Now, it's not going to be much of a challenge. The more you increase that speed, the more of a challenge this ball will be. Okay, that's it for today. Make your modifications, make it a great game, and we'll see you later.